Hi, everybody. I'm Brittany, and today I'm happy to present Erin Dahl. She is a research assistant in the Karstens Lab at OHSU, and they focus on using bioinformatic tools to understand complex human disease. Today, she will present her work that is aimed to improve visualizing microbiome data using the microshades package in R. Take it away.
Thank you for joining me today. Do you see what I see? In this picture, I see an elephant, but not all people can. I'd like to introduce microshades, an R package for improving color accessibility and organization of complex data. Our main motivation for this project was to create a color palette that is accessible to individuals that experience color vision deficiency, otherwise known as CVD. CVD impacts roughly 300 million people worldwide, which is comparable to the current US population. CVD refers to partial but not complete color blindness and diminishes the ability to distinguish certain colors. The three types of CVD are deuteranope, protanope, and tritanope. Deuteranope is the most common form of CVD, also known as red-green color blindness. Protanope is less common than deuteranope, but described as mutated red pigment and less ability to discriminate colors. Tritanope is relatively rare, but known as blue-yellow color blindness. One of the current leading accessible palettes is the Okabe-Ito color palette, which, as you can see when run in the three different types of CVD simulations, is universally CVD friendly. This is great. However, this palette is limited to 8 colors, which is not sufficient for visualizing complex data. Our solution was to develop an R package that incorporates shading for expanding the number of colors available to 30, with the goal of continued universal CVD accessibility. Our lab also works with complex microbiome data, so we wanted to make sure that we could use these colors with our data and created functions in this package that would apply microshades palettes and assist in additional data organization. We developed 2 microshades palettes. However, for the purpose of this presentation, I'd like to focus on the universally CVD-friendly palettes. This palette includes 6 base colors with different shading applied to result in a total of 30 colors. This next slide shows the microshade CVD palettes under each type of CVD simulation. So you can see deuteranope, protanope, and tritanope. These colors are distinct and therefore universally accessible. Microshades palettes are easily accessed with our package and can be applied to any plot. This plot examines car fuel efficiency on the highway versus city in terms of miles per gallon. The points on the plot represent a car with a particular type of drivetrain and cylinder engine. This first plot uses a default coloring system, which provides no meaningful order to the coloring. This next plot uses microshades colors, which allows for the viewer to notice trends easier. Each drivetrain is a different color, and the number of cylinder engines is represented by a shade of the drivetrain color. With this color organization, we are able to visualize that front-wheel drive cars tend to have the highest city and highway miles per gallon. Additionally, cars with fewer cylinders tend to be the most fuel efficient. This color organization is not only accessible to all, but is additionally helpful in noticing trends. Another example of microshades in action is this microbiome data example containing relative abundance data for various samples. In this plot, the color represents different bacteria in each sample, and the colors are determined by the default ggplot color scheme. This next plot contains the same relative abundance data with the same sample order. However, this plot uses the accessible microshades CVD palettes. The colors are organized and better represent the phylum genus classification of bacteria found in the samples. If you look at the firmicute samples circled, you can tell that the CVD colors drastically improve the distinguishability of colors. This last plot uses microshades CVD accessible colors and microshades organizational functions so that the layout of the data further improves visibility of trends. Microshades was also used to generate a custom legend that further shows the organization of the data. As you can see, there are many benefits of using microshades, and a small change of using a palette that is CVD accessible will make your work interpretable to all. So thank you for joining my presentation, and please visit our website to learn more about how you can use microshades.